Okay. So we're going to do the chapter series today. The series chapter essentially has three parts, which is number series, alphabet series, and letter series. We will start off with number series right now. I'll talk about alphabet and letter series slightly later. Before we start number series, what I want you to do right now is pause this video and write down the squares of all the numbers from 1 to 25. And write down the cubes of all the numbers from 1 to 15. And I want you to have this set of numbers in front of you. You need to be familiar with all of these numbers because these are the patterns which are going to be used while solving these series questions. You will find that the series revolves around either squares or difference of squares or like difference from cubes. So until and unless you know the values of squares and cubes, then only you can solve these questions. So you just need to be familiar with the values of squares and cubes. So for example, 169 is 13 square. You should know that 169 is 13 square, and it is. So if you get a value like 171, right? If you get 171 and 198, you know that 171 is 2 more than 169, which is 13 square. 198 is 2 more than 196, which is 14 square. Right? So you know there's a pattern which is forming over here. Okay? So let's look at this series over here. We need to find out what is the next number in this series. Okay? Now, any series that we get, let's essentially just find the difference between the two numbers. Okay? What is the difference over here between 7 and 12? Difference is what? 5. Right? Again, between 12 and 17, difference is 5. 17 and 22, 5. 22 and 27, 5. You can see that there is a pattern which is being formed over here. So naturally, the next number will be what? 5 more than 27. Right? What is 27? 5 more than 27, which is 27 plus 5, which is 32. So that is your answer. Right? Now, one process is looking at only the difference. We have another type of question where, okay, what is the difference between 7 and 12? We have 5. Right? What is the difference between 12 and 19? 7. Difference between 19 and 28, 9. Difference between 28 and 39, 11. Now you notice that there is no pattern exactly just like this previous question which is formed over here. So to see there's a common pattern which is forming, we can find the difference of the difference. So let's find that. What's the difference between 5 and 7? 2. Difference between 7 and 9? 2. Difference between 9 and 11? 2. So the pattern is formed over here. Right? So the next difference of difference will be what? 2 again. So difference over here will be what? 13. So the next number will be what? 39 plus 13, which is 52. Okay? So did you understand the two essential ways in which you need to go about solving these questions? Right? Now, you always need to keep in mind the values of squares and cubes. Why am I telling you that? Please look at solved examples 2 to 5. You will understand exactly why I asked you to write down the squares and cubes. So on page 75, solved examples 2 to page 76, example 5. Now, we looked at a series previously where we saw that the difference between the two numbers or every part of the series was the same. Right? Now, the series which has the difference between two consecutive numbers same is known as an arithmetic progression. So, for example, you start off with say 2. Right? So, the next number is 5. Then you have 8. Then you have 11. You notice how the difference over here is 3. The difference here is 3. This is also 3. Right? So using the same pattern, the next number will be 14. Right? Now, if I write down, let's try to find a generalized form of arithmetic progression. If I write down 2 as A, right, which is the first term of the series, the next term of the series will be what? A plus D. After that is A plus 2D. Now what is D over here? D is the difference between the two terms. So in this example, this value is D, this value is A, right? The difference between the two terms is 3, which over here is D. D represents the common difference. Okay, look over here. A plus 2D. A over here was 2. D was 3. So 2 plus 6, which is what? 8. Right? This is how the series of arithmetic progression continues. Right? Now this was the first term. This was the second term. This is the third term. This is the fourth term. Right? Do you notice how when I said the fourth term we had 3D over here. The third term we had 2D over here. Right? So we have to find the nth term, right? You will say the nth term is A plus n minus 1 into B. So say you want to find the 15th term of this series, right? You know the first term is A, right? 15th term, first term is 2, 15 minus 1, B. So you have 2 plus 14 into 3. 14 into 3 is 42, so 44. Okay, why am I telling you this? Is so that you have basic understanding of arithmetic progression is. If you see this series, you can immediately find out the next term of the series. Okay, so the next type of generic series is called geometric progression. Okay, geometric progression, just like the difference in arithmetic progression was the same, in geometric progression the product is essentially the same. What do I mean by that? So if your first term is say 2, right? Your next term is 10, after that is 50, after that is 250, right? After that is 1250. Yeah, so you need to find out what's the terms after that. Here you see that the difference is what 8 over here, difference is 40, difference here is 200. It is not, doesn't have common difference. But notice how 10 divided by 2 is what? 5. 50 divided by 10 is what? 5. 250 divided by 50 again is what? 5. 1250 divided by 250 is what again? 5. Right? So over here, instead of a common difference, there is a common ratio. Here, R represents a common ratio. Right? So if I take 2 as the first term, the second term will be what? A into R. Right? What is the common ratio here? It is 5. 2 into 5. Yes? The next term will be what? This into this is 5. This term is AR. This will be what? AR into R, AR square. This is the third term. The fourth term will be what? AR cube. And so on. Right? So if you want to find the nth term of the series, you can see over here also. Second term is AR, third term is AR square, fourth term is AR cube. Right? So the nth term of the series is A into R raised to n minus 1. Okay? So say if I want to find the 10th term of the series, it will be 2 into 5 raised to 9. Okay, I hope you have a brief understanding of what geometric progression is. Just go through and do solved examples 6 and 7. Look at the examples which are mentioned in the arithmetic and geometric progression also. Just get a brief understanding of what it is. It's not a major part of the number series chapter, but you should understand what it is. Once you've gone through that, you can very easily start solving exercise 3A. Okay, please take, I think so you should solve questions 1 to 15 of exercise 3A. 1 to 15 questions, 1 to 15 of exercise 3A. Also, please go through exercise 3B. It's self-explanatory, right? It's very similar to what we've already done. Exercise 3B. It's on exercise 3B. It is exercise, the part of exercise 3 already. It's on page 86. Please do questions 1 to 15 from that too. It's self-explanatory, you understand if you just go through it. Let's move on to alphabet series. Okay, alphabet series, if you go through the first question, first solved example on page number 91, you will see that you have letters which are given to you. As was mentioned previously in the coding decoding chapter, anytime you see letters in reasoning, you need to convert them into numbers. Now how do we, let's revise quickly, how do we convert letters into numbers? We have A, B, C, D, all the way to X, Y, Z, right? To convert letters to numbers, we have A is 1, B is 2, C is 3, D is 4, we have 24, 25, 26, right? Now it becomes really difficult for us to remember all of this. So to make our life easier, we have this, EJOT. What is this? E stands for 5, J is 10, O is 15, T is 20, Y is 25. Right? Okay, so instead of, say, if I ask you what is the value of P, instead of counting from A, B, C, D, E, F, G, H, I, you start from the closest letter you know over here. Right? So the closest letter to, say, P is O, LMNO, P. So O, you know, E, Jo, T is, O is 15, P is then 16. Okay, I hope you understood this. So essentially alphabet series is very similar to number series, but what you need to do is you need to convert the letters to numbers first. So let's take a look at the first example. You have Z, X, V, T, R, and you have two spaces. Okay, let's write down the numeric values of these letters first. So you have Z, which is what, 26, right? X is what? You have X, Y, Z, you have 24, right? Then you have V. How do you get to V? You know EJOT, you know T is 20, T, U, V, so you have 22, T is 20, then you have R, which is what? EJOT, O, P, Q, R. O is 15, P is 16, Q is 17, R is 18. Right? Okay. You can see what pattern is being formed. 26 is minus 2 is 24, 24 minus 2, 22, minus 2, minus 2. The next two numbers will be what? 16 and 14. Right? Again, remembering EJOT by EJO. O is 15, P is 16, right? Okay? And you know EJOT again. O is 15, so 14 is what? LMNO. So MN and P. So your answer is P and N. Right? So this is how do you go about doing alphabet series. Right? Anytime you get letters, you convert them into numeric values and you will see the patterns in the numeric values. It's difficult to find patterns when you have only letters. This is the process which we followed while doing coding decoding. Same process we will follow while doing alphabet series. So once you understood this, please try the solved examples from 1 to 4, which is on page 91. And after that, do questions 1 to 10 from the exercise on page 92. Move on to letter series. Okay, in letter series you notice that there are letters again alphabets over here, but the alphabets here are in the lowercase, right? When you have lowercase letters like this, please don't convert them to numbers. There is another way in which we go about solving this. So this is the question which has been given to you, right? Now you have these letters in your spaces over here. These letters in your options represent what letters would go in this space, such that a pattern forms in this series, right? So if you take this option, say this option is, you take this option, this has to be correct. You will put B over here, A over here and A over here. Right? Once you put these values, you need to check if there's an actual pattern which is being formed. Okay? So let's try doing this question. Right? Let's look at the first option. So you have B over here. So you have A, B. This B will come over here. Right? Then you have again A. And again this A will come over here. Then you have B, A. Right? There seems to be a pattern over here. You have double A, double B, 4 A's and double B, double A. Right? It seems like A, B, B, A, B, B, A is the pattern. Okay? Let's see if there is another option which fits a proper pattern. Okay? You have again A, B, A. Then you have A. You have B, B. And then you have A, B. You can see over here there is no pattern which is being formed. You have A, B. So you can definitely reject this. Right? Let's try the third option. Again A, B. Then you have 3 A's, 4 A's you have over here. Right? Because of this A. Then you have B. Again, there is A, 4 is B. Again, it is not repeating. You can reject this also. You have A, B. Then you have this A, which fits over here. Then you have 3 A's, right? Then the next A, right? Then you have B. Again, there is no repetitive pattern which is being formed. So this is rejected. Let's try the last one. A, B, right? Then you have 3 A's. You have B again, B's and AB. Right? Again, you can see there is no pattern being which is repeating. Here you can see this is our answer. The pattern is being repeated. A, B, A. Then again A, B, A. So this is your correct answer. Right? This is how you go about solving this type of question. Right? From these options, fill in what is there in the question and see if a pattern is being formed. If you find a pattern, you can immediately mark that as the correct answer. I wanted to show you that this is the only correct answer and these others don't have actual patterns which are formed. Okay? You can do the exercise on page 98. You can do questions 1 to 15. You'll get a much better idea as to what we're talking about. Okay? Exercise questions 1 to 15 on page